Yes.
Okay.
Okay. So, welcome. Do you want to? I'm Wendell. This is level one, obviously. You want to introduce yourself?
Yeah, I'm John Bach with Puget Systems out of Seattle.
Woo! So, Puget Systems makes hardware, PCs, stuff like that, for discerning customers. Like, you want a ready-made system that you don't have to think about and it just works. Puget, right?
Yeah, I
Or
mean we're pretty enthusiastic about the use case of the computer, and so for us it's all about getting a job done. And so when content creators or engineers or scientists can get a job done, like that's our job. And so we have to know hardware, but we have to know the workflow and we have to know the software just as much.
And so it turns out I've been a fan of Puget Systems for a really long time. So I'm sort of super excited to have you on. I didn't really think of you as like the face of Puget Systems or whatever, but I've definitely recommended Puget Systems in the past and for many years. And by way of example, look what I found in the basement.
Oh, it's terrible.
It's ancient though. Yeah. Don't look at it as a current example of anything from
Look
Puget
at the
Systems.
beige.
Beige CD-ROM. It's a silver. This is I know this under the name Chief Tech, but I think this is like you were saying it was your first group buy or something, but it's lightweight. It's nice.
Yeah, yeah, we bought those from a company. Believe it was Chemming back in the day, and yeah, that was we were running out of my house, and that was my first like volume deal. So we filled up bedrooms with them.
They that was a specialty computer that was ordered for audio production and like audio stuff, and Puget Systems was one of basically like it was exactly what you were saying. It was purpose built to solve a problem for a specific user, and it was literally in use from whenever, like probably circa 2002 or 2003 until a few weeks ago. Like literally that, and it's being upgraded, and there's nothing wrong with it. It's just that it's
It's amazing.
time.
Yeah,
So
yes, yes. Well, I'm happy you didn't show the wiring for very long.
well, I think the wiring might be. I think you guys did a better job on the wiring. I want to
Oh,
say
did
that.
you redo it?
Yeah. I want to say that maybe the power supply was upgraded to support a different graphics card or something like midway through. Because
Okay.
I think what's in it now is like an Antec Earth Watts or something. And I'm not really. I don't know, but I think that you guys probably had all the wiring tied down and stuff. So it's untelling how this thing has lived through the ages, but Puget Systems has been around for a long time, and
Hmm.
also your articles. Your articles are the other thing that sort of has kept you on my radar because you guys have always done really good write ups of like if you're going to run, the Adobe suite, or you're going to run these Autodesk programs, or you're going to do this type of other thing. The articles have always been really handy for me to go and read what your guys' experience are with different
Yeah.
software packages.
Yeah, well, thanks. Yeah, I mean, we saw that in the industry there was a lack of information for that kind of targeted benchmarking and analysis. It's really easy to find Cinebench scores and gaming benchmarks, but not so easy to find like V-Ray rendering benchmarks. And so, yeah, we take it on, and it's really important to us that we're public about it. Like we want to be transparent. It's just information to help everyone.
Yeah, and I mean, some of that content is the kind of content that I want to do. I hope that we are able to do more of that kind of sort of qualitative and quantitative testing in the future. But as like it always blows my mind that there wasn't really anybody out there doing that for those kinds of things. And I mean, this I don't I don't want to like get you in trouble with any partners or anything, but having customers that I support with Autodesk, my experience with Autodesk support has basically been not fun. And knowing that there's a partner that will work with you and is sort of pre-built and has sort of been through the paces with particular program suites, not naming names, Autodesk. It's nice to know that it's like, okay, look, we've already done everything. There's some gotchas here and there. There's some performance penalties here, and we were talking the other day, I think, and just the changes in processors and all of the all of the other stuff like that has meant that things are not really as stable as they once were. You can't just like
No,
cherry pick a few things. So
no, no. Unfortunately, no. Yeah, I mean, with the tech support, I mean that's kind of the standard these days, right? Is crappy tech support. So when we first got into this whole approach to our business, the thought was like, okay, we're going to be really good at like researching what to build for specific applications. And then when it comes to support, we'll foster a relationship with these software vendors and we'll hand off the tech support. Well, that doesn't work out very well. When you have a certain bar of customer experience that you want to maintain, then how do you hand off to this? You just can't. And so we take on more. And so now it's not just like we have a couple guys in labs that are doing this research. Now that the training on all these software platforms is a company-wide effort for us. Because that's what it takes. That's what it takes to get the job done.
And that's part of the value add for, at this point, anybody can put a computer together, but then there's some stars and asterisks and gotchas, and it's not that easy. I mean, when you want to even build like like the new AMD 2990, it's like I want to build a system around the 2990. You can really easily make some mistakes that are just totally going to kneecap that system, and it might have a 2990, but it's going to run like a 486.
Yeah, yeah. I mean, if your goal is to build a computer, then build a computer. I mean, it's a great experience. It's a great learning experience. But if your goal is like you need to do post-production work for your small independent film studio, then any time that you're spending building a computer, you're not doing your craft. And so our goal is to get people to be able to do their craft, make their living.
I also like that, well, like with video production, you mentioned the system that you need for Adobe Premiere is probably, I think, is a different system than what you need for like DaVinci Resolve.
It can be, yeah. I mean, yeah, and that's often a challenge for us. That like building the perfect Photoshop system is very different than building the perfect Premiere system, and that's all great if like all you do is Photoshop, but nobody does that. Everyone's using a mixture of programs, and so for us, it's about figuring out what hardware is used by all these different programs, and then we have to have a talk with every customer. I mean, one at a time, every customer, to figure out what is your mix and how important is Photoshop to you versus Premiere and rendering. And then you kind of build a machine that's tailored for that. Like, if you only use Photoshop once a month, you use Premiere every day, then we're going to build you like a 90% Premiere system that still does okay at Photoshop, right?
And I like that you have the empirical data from all of the testing, and you've done the homework to really know what the options are and all that kind of stuff, which is why I've been recommending Puget System. Well, that's like over 10 years.
That's awesome.
Almost that's over 15 years. Jesus Christ, I'm old.
Is it? That's
oh
awesome.
My God, it's getting old. No, it's terrible. Okay. So that's we're not going to talk about Puget Systems this entire stream. That's crazy. But we do, because you have exposure to a lot of hardware. And so my goal for this stream is to sort of share your experience. Like okay, we've put together a bajillion systems, and in general, what of the quirks have been, because we're all about quirks, like what all's going on. But also, we sort of want to talk about the industry and sort of the shift, because we were talking a little bit before the stream, and I think that this Core Wars thing on the desktop is really starting to cannibalize the lower end server and workstation market for Intel, and AMD is clawing its way back into the data center with that, maybe. But also, it's kind of related to that is the whole like hardware bugs, meltdown Spectre thing has really thrown a wrench into things, and we may see an acceleration of the deprecation of hardware in the data center sooner than it otherwise would have been. So let's talk about like core counts and like okay.
Yeah.
So my hypothesis is that things on the desktop are actually getting flakier than they've ever been, and it is really hard to pick a combination of hardware that is stable. But you've built a billion systems. I don't have access or exposure to that many systems. What's your experience been?
Yes, you're absolutely right. What has happened in recent years, especially as like the competition turns up, is things are brought to market more quickly, and then it's like let's figure it out on the fly. And it leads to mistakes and problems with testing. But I mean, frankly, for a company like us, that's then becomes our job. It's like the things that are missed in the QC cycle at the hardware manufacturers become our job to fix. And I mean, we went through a pain point as well. Something that we discovered, maybe it was about a year ago, was that we had always had a testing process we put all of our systems through, and it's kind of a one size fits all testing process. Like it represented all the different types of software packages we went after, but we were doing Prime 95 and FirmArc and of course like MemTest and Cinebench and LinPack and like all these different ways to stress the system, and the computers were passing just fine. And then we fire up Premiere and we go to export a video and blue screen, and that was our first taste at at the metrics for how we test our systems had to change because we had, for the first time in history, it was systems that were stable in synthetics were not stable in specialty applications, and we had to like flip our whole testing process on its head. And now, if you buy a system from us, we have to have a discussion of, well, what software packages are you running? We still go through the whole suite, but then we go into an in-depth test suite that we have built in-house, running actually that software that you'll be running, and because we found that's necessary. We had problems that were cropping up in the field that we weren't catching in our generic process, and so I've come to view synthetic benchmarks as it's a great way to overall stress the system, and it's a great way to test your thermals and things like that. But if you want to know if your workload is stable, you need to run your workload on it.
Yeah, that's definitely been my experience as well. I've also found that a lot of the impetus around like power management and like good, it's like because you think that you don't
Yeah.
have to worry about thermals as much on the power management side, but it seems like it's even on Windows. Like I mean, I'm spending a lot of time in Linux here, and so like some of this I chalk up to like stuff in the Linux kernel that is maybe not as polished as it should. But I spent a lot of time for a lot of the videos that we worked on in Windows with power management, and it seems like when I disable all of the power management features, the system is suddenly insanely way more stable, even at higher clock speeds.
Yeah, yeah, no, we found the same thing, and we have seen it more on Linux than we have in Windows. I think Windows just is a little bit more recoverable in some of those situations. But yeah, I mean, example of that we had from maybe it was 2 years ago now, was when we were building GPU boxes. This was like the machine learning was just becoming a big thing. We were doing a lot of GPU boxes, and we were finding that under certain workloads we were having PCI bus errors, and it's driving us nuts. And we were going through. Sometimes like replacing the riser in the server would fix it, and sometimes we had to replace video cards, and sometimes replace the motherboard, and it was driving us nuts trying to pin down what the problem was until we discovered that we could just turn off power management and everything was fine. So yeah, I think that there is more and more call for power efficiency in the data center by government regulations, and that's causing the hardware manufacturers to like push that bleeding edge of how far they can take it, and it goes a little too far sometimes.
That is a really interesting angle because one of the, I remember Haswell, and it was like, oh, we've got the fully integrated voltage regulator now, so we can
Yeah,
switch modes super quickly. And Intel was pushing about how their laptops could go from 800 megahertz to like the full 1.2 gigahertz in a matter of microseconds instead of milliseconds. And I'm sure that there's a desktop equivalent of that. So that's a really interesting angle that some of the stability issues that we've both encountered are probably related to issues with the issues with the overall platform power management and not having that worked out yet.
sure. I mean, I guess in some ways it's kind of two sides of the same coin. That if you want faster speeds, you often have to pump more volts into it, or conversely, if you want to get the same speed at lower power draw, then you drop the volts down. And yeah, I mean, we just hit that edge. I think the world that we live in now is just it's very diverse, and honestly, like I don't even know how much I fault Intel, AMD, NVIDIA for things like this because there's so many things to test, and we're all just kind of running at a sprint. And yeah, I think what it kind of speaks to is like you just have to specialize. I think whether you're a provider or a hardware manufacturer, I think specialization is key at this point.
No, I think there's a lot of evidence from OEMs for that as well because thinking about some of the testing that other channels have done with things like the load line calibration on the CPUs, and it's like, wow, this seems like this should be a safe voltage, but then when this CPU really gets loaded down, this particular motherboard is delivering an extra 100 millivolts or whatever. And that's probably because those guys have encountered the same thing in testing to do that. I mean, when I've been testing an Intel 8700 in an OEM system that is designed for that 65 watt, TDP, just using like the Intel, like the Intel overclock master utility,
Yeah,
whatever, that just opens turbo. Like all it does is open up the turbo. It will introduce stability problems into some OEM systems with some workloads, but not others. And that's just the CPU operating totally in spec, not even really like a K part, just something to monitor it. But if you cap it at like 3.6 gigahertz or 3.8 gigahertz or whatever it is, then it's basically fine. But you're not actually able to achieve the turbos, sort of as advertised. And it's
yeah,
really interesting to hear that you guys have basically encountered the same thing at scale with much higher end hardware than the OEM hardware that I'm even working with.
Sure.
So
Yeah. Yeah. Well, it was also about 1 or 2 years ago that we started doing. Uh, we made a terrible mistake. We started measuring things more carefully and realized that everything's messed up. We we started testing on every system we sent out. We would load up one core, load up two cores, load up three, and we would make sure they were running at the advertised frequencies, and like they weren't. And it was just a mess all the time.
yeah,
And so we ended up having to have a lot of conversations with the OEMs, with like Asus, Gigabyte, MSI, to really get to the bottom of it and get those things corrected. But yeah, it's one of those things like the deeper you look, the more the rabbit hole extends beyond you.
and then it's like, well, if I underclock this or if I undervolt this CPU, all of a sudden it can clock higher and seems more stable. What's going on?
Yeah.
I don't understand. Well, not just the stability, but which may or I don't know if that's I'd always attributed that to just clock speed, but I'm starting to think that clock speed plus power really is part of it because anecdotally for me disabling power management, I'm still able to keep like the 4.8 to 5 gigahertz clocks. Things are a little different on the AMD side with precision boost overclock. That does a better job than manual overclocking, but in terms of like heat production on the Intel side, especially with the 8000 series CPUs, I heard a rumor the 9000 series CPUs are going to be soldered again, which is odd.
I heard a rumor too.
So I don't know. It's gonna be really interesting. But
Mhm.
in a short time, we've moved from 4 cores to 6 cores on the Intel side, and maybe it's probably gonna be 8 cores on the desktop side pretty soon. But I'm looking at the 6 core X299 part and contemplating a hypothetical 8 core part in that same socket versus the X299 counterpart, and it seems like those X299 parts maybe shouldn't be.
Well, I mean, I guess depends on who you are. Yeah, I mean, with all the competition that's been happening in the last few years, yeah, I mean, from both sides, for both AMD and Intel, we've seen them be more aggressive. And one of the ways that they can be aggressive is to unlock more on the consumer side that used to only exist on the server side. And I mean, that's a natural result of competition, and I think we should be happy, right? That people are being that they're being pressured into doing those things. It does make
Restated,
things well.
restated. It doesn't matter if you're team red or team blue. We got more cores for you.
We do have more cores either way, yeah. But it definitely makes it more complicated because I mean now we have all these different routes that we can get to. Okay, we have to make a box that's for Premiere for DaVinci Resolve, and it scales very well across multiple cores. And so now we can go Intel, we can go AMD, Core i9, we can go Skylake W, we can do the new scalable Xeons. There's all these different choices, and so it's a lot of work. There's a lot of benchmarking we have to do.
on the on the server side, it definitely seems like the last couple of generations from Intel, they've been really, really carefully balancing a low number of cores with a relatively high clock, or a larger number of cores with a relatively low turbo and low set of clocks. It really seems like they're trying to avoid, except for possibly the Xeon Workstation part, which we were talking a little bit about before the stream, but it seems to me like they're really, really trying carefully not to cannibalize their market. And AMD is just stomping in like a bull in a china shop, and they're just like, cores, clock speed, we don't care, whatever you want. It doesn't. We'll sell you whatever.
Yeah, that sounds right. I mean, they have they're the smaller guy in this fight, and so they have more that they need to bring to the table. So it makes sense.
There is a lot of really attractive things on Intel's platform, though. I mean, you've got like 6 channel memory. The newer higher end Xeons look like they're going to be really exciting, but I don't. They're at Computex they demoed that super high end processor with the 1 horsepower cooler or whatever it was,
Yeah,
running
yeah.
at 5 gigahertz, and they said that they were going to have that as a product by the end of the year. And I would actually like to see a processor like that on the desktop in that socket with 6 channels of memory on the desktop, because I think that dual socket workstations are probably basically going away. But I'm not
Yeah,
sure
I
what your
agree.
experience with that is.
No, I totally agree. I mean, it's so much more simple to have that single socket, and we don't have to have the crosstalk between the sockets. it makes things a lot simpler. It makes things a lot more scalable. Scaling across multiple cores on one CPU is a whole lot more efficient than going across two. So no, I'm enjoying the fact that we can now do so many cores on a single socket because it opens up so much more opportunity without making things complex. Like things can continue to be simple. And yeah, no, I mean yeah, it's been interesting as all these different platforms is coming out, and then so AMD will launch Threadripper, and then Intel will have an answer, and then AMD will have an answer. And when we first started offering Threadripper systems, we did started offering when they launched Threadripper, and at the time, it was it was such a perfect answer at the time because you had the complicated stack from Intel that had all you had the Kaby Lake X and Skylake X, and it was all different lanes per CPU. And AMD came in and said like, we're just going to give you a bunch of cores and a bunch of lanes, and it was really appreciated. And at the time though, the biggest benefit we saw to the platform was the fact that we could do these GPU boxes. We were doing GPU boxes for rendering and machine learning, and Threadripper got us all those lanes, and yeah, I think it was basically just all the lanes. And so Intel had a great answer with Skylake W. They came in, and now they have the Skylake W, the Xeon W parts, and those offer it's a same type of thing. You get the same number of lanes. I think it's 48 lanes on each CPU. And by the way, the first the entry level Skylake W is cheaper than the entry level Threadripper. So at that point, okay, we're building boxes for GPUs. It makes sense now to shift over to the Intel side again. And then AMD comes out with Threadripper 2, and it's just the ping pong ball keeps going back and forth. And
it is exciting, though. I mean, what an competition! Everybody wins. It doesn't matter what your preferences are or which way you swing. I mean, it's the current generation Xeon W processors are those on a 4 or 6 channel memory configuration in terms of like memory bandwidth at this point?
Oh, you know what? I'm on the spot here. I think it's 4 channel.
I think it is. I think it is too. I think that there are some upcoming 6 channel parts, but I don't know. I know that they're already out on like the super high end, but I don't think that there are any WS parts that do that.
It's a pretty great platform for us because it has all those features. It has all the lanes. It has registered memory support. It's a nice, just the stack is so simple, which is so appreciated. Back in the day, I remember when X99 launched. At that point, that chipset was pulling from the server group at Intel, and that led to some pretty interesting things. Like you can put RDIMM on X99, and we were doing that all the time.
They did not advertise that.
No, but it worked. And it was great because we could offer all that frequency and get that speed from the CPU. But then for these workstation applications where we really needed 256 gigs of memory or more, we could do it. Yeah. And so that's what I appreciate about Skylake W is like we have all of that and it's official. Like we all have that's on the QVLs. We can do that with the registered memory.
Yay! That is good. Registered memory is not something that works on Threadripper, as far as I know.
I don't believe so. No.
I think it's
you have ECC, right?
Yeah, you can do unregistered ECC, but I think you can only do 128 gigs of unregistered ECC right now with all 8 channels on Threadripper. But Samsung has had 32 gig RDIMMs for like a year now, so that would let you do 256 if it did registered memory. I think. Because it seems like I ordered some systems that had that much, but
I want to say there's even bigger now. There's times we have to jump over to LRDIMMs to get those super high capacities, but it's amazing actually how many use cases that's necessary for.
Yeah. Well, that actually is a good lead in for the next topic, which is we're in the core race, but for let's call them plebs. For plebs, I'm not really sure that beyond 6 or 8 cores, it really makes as much of a difference. Like I don't think the software has caught up. But for businesses, it's a totally different ballgame. So let's talk about both. Let's start with the individuals. I think from 4 to 6 cores is a huge difference, and from 6 to 8 cores is less, and from 8 to 16 is practically nothing for an ordinary user.
Yeah, I would agree with that. I mean, I guess it still depends a little bit on what you're doing, but for the more normal like home use, email, office, gaming, I totally agree. At some point, like you get benefit just from the fact that you can have multiple tasks going on. Like now you can be running your game and your antivirus can be running in the background and it just kind of shares the cores. And so I think to some extent you get like a free pass. Like as you add more cores, your system becomes faster because of that. But that only works so far. And at
Yeah.
that point, you have to have an application that scales across multiple cores. And in gaming, yeah, we see up to quad core scales pretty well, and then after that, it just starts dropping off.
It's Amdahl's law. I think it's like if one painter
Yes,
can paint a room in an hour, could 64 painters paint a room in a minute? And it's like that's just going to be a blender of paint. Like
yeah,
nothing's going to get done.
yeah, yeah. We have so one of the guys we have on staff, Dr. Kinghorn, PhD in quantum computational chemistry. He's been awesome to have here, and he is our scientific advisor for everything that we do on the HPC side, which is basically everything's machine learning now. And yeah, he gave a whole lecture to our company on Amdahl's law, and that was a fun day. Got to hear about even super scaling, where things are even faster the more cores you have, and than 100%. And yeah, that's exactly right. I mean, the law is that with every application, there's a certain factor you can apply to how well it scales. And honestly, with most applications, it's terrible.
Yeah,
and so
yeah.
and so you really want that single thread performance in order to get you most of your home and gaming type of tasks. But yeah, they still stack up a little bit, and so having 4 or 6 cores is nice.
The interestingly, well, there's two things related to that. One, we did a recent video on Numa to just help like people that are buying Threadripper are getting odd results from gaming. And so I made an attempt at explaining Numa and how that can affect gaming, but also how you can still run a Threadripper because the penalty for cross-die communication in Threadripper is not nearly as bad as the penalty for cross-die communication in a dual socket system, and that'll be true whenever Intel goes chiplet as well, I think, and for like the higher end stuff and all that kind of thing. But at the end of the day, if you still make certain assumptions about how the system is architected, so like if you use PowerShell or Process Lasso or just the Windows Task Manager, and you pin your game to the CPU cores that you know are local to the I/O, at least for the game, so that it can communicate with the graphics card without having to cross a die, you still will realize a performance benefit.
Yeah,
And the operating system is not built for that. The scheduler is not built for that. And for like massively multi-thread things, we don't really even have programming languages that are built for that. I mean, we've got like Go and Rust, which are more appropriate for that. And Amazon and Google are sort of pushing that as like for their services APIs. But in terms of like desktop applications, the computer science for that, I think, is not quite there yet. But for
yeah,
machine learning and things that parallelize really well, you can still take advantage of that on the desktop and run your experiments and video rendering to an extent. But even video rendering is weird. So like if you run Handbrake on like the 2990WX, I've got a 2990WX that I'm testing for ASRock right now, and Handbrake is basically not great at scaling past like 16 cores. But if I've got a folder full of level 1 videos that I need to transcode, and I run Handbrake and tell Handbrake to run in one thread, and I tell Handbrake to run 16 or 32 copies of Handbrake for 32 different files, that is much, much faster than having Handbrake just operate itself on a single file for a transcode. And that's just
yeah,
a software optimization problem.
yeah. I mean that makes sense because it's only actually certain subroutines in Handbrake that are multi-threaded,
Yeah.
and by doing it yourself, you're
Yeah.
you're getting it all.
Yeah, it's just, but it's got the batch functionality. It's like you could totally like somebody could just go in there and say,
Yeah,
"Oh, I've got this batch of files I could do. Why don't I just kick off 8 at a time?" And maybe they've
right.
added that feature. Or they're working on that, but I couldn't get that to work the last time I tried it.
So how much performance benefit did you get by locking the threads to the NUMA core?
Oh, for GTA 5. So GTA 5 is super interesting. We got the MSI like Gaming X Trio, which is like the fastest 1080 Ti that we've ever had. It's like 2 gigahertz out of the box. It's crazy. And so that MSI 1080 Ti will easily clear like 170, 180 FPS in GTA 5 on like an 8700K. Oh, that's overclocked. And with the Threadripper in Numa mode, just letting the operating system handle it, it was on the order of like 150 FPS, something like that. And if you switched it into UMA mode, it would drop to like 135, 140 FPS. And
Oh,
if you put it in UMA mode, but then you pinned the processes to the cores that you knew were physically associated with the graphics card, you would get most of the performance back, but not all of it. because Windows was not handling the memory allocations. My theory is that I think Windows was still maybe allocating some memory for GTA 5 cross die, so there was some extra memory latency, but we did away with the I/O latency by making sure that the game only ran on the cores associated with the die that was connected to the graphics card.
Yeah. Wow. Okay. We haven't done that
So
before. That's an interesting thought.
it's you get, I mean, with things like 7-zip, 7-zip will perform better in UMA mode because the cross die latency just doesn't matter for 7-zip. Like, it doesn't affect the workload. But with GTA 5, or games in general, because it depends on, like, processor does something, the graphics card does something, and then communicates back to the CPU, and the back and forth, the latency, I think, is why some workloads are affected and why some workloads regress. And with like AnandTech did all these really amazing benchmarks with like the 2950 versus the 2990, and the 2990 has those two 8-core hidden nodes. But I think because Windows doesn't know how to treat those, how to do anything with those, it doesn't know that maybe I shouldn't put processes on those hidden nodes, and it does, and then so you have performance penalties because there's no memory associated with them either. So you're going to have crazy memory latency to those hidden hidden nodes. But you still get, 10 to 40% of the benefit that you would if those were directly connected to memory or whatever,
Yeah.
which is, depending on the application that you're using, could be good or it'll hurt you.
Yeah. It's interesting how now with Threadripper kind of bringing these problems to the desktop, it's like now now the masses are experiencing what you've dealt with for years on the server side.
Yeah. So on the high core count Xeons, that most of those will still have direct access to memory, but the high core count Xeons not all the cores have access to I/O. So if you're building a web server, for example, and you want the web server to go as insanely fast as possible with encryption, it's like, oh, we can just have the hidden nodes handle the TLS encryption, and the nodes that are directly connected to the bus can handle our dual 40 gig Ethernet interface. No, the high core count Xeons were garbage for that workload, utter garbage. Like the 16 core was the sweet spot of like price performance, and the single socket systems did better than the dual socket systems, which seems crazy because it's like I've got twice as much bus bandwidth to deal with. Nope, debugging that to the bare metal, that was a mutex problem. The mutex synchronization across the quick path or whatever was too slow. So it literally made more sense to just buy multiple single socket servers for that application, which is insane. Like, did nobody test this in the Intel lab before they sent it out the door? Because this is like a basic use case.
Well, and this is why you now see Skylake W servers.
Yeah. I mean, it's just, let's just do a rack mount workstation in a CPU in a server, And so, you got to know that Intel, somewhere inside Intel, because Intel is the captain of product segmentation, somebody inside Intel is like, we really got to figure out how to make sure that the workstation people only buy workstation CPUs, and the server people only buy server CPUs. And maybe that's like the 5 nines reliability or whatever. Because I was thinking some of that flakiness that we were talking about earlier was, it's like, well, maybe we just make the workstation CPU a little flaky. And
I see. Well, I mean, that's where those worlds intersect. Server and consumer is where we've lived for 10 years now. It's always been really murky. Like, what is a workstation? Is workstation like a really high-end gaming box, or is a workstation kind of a low-end server? And honestly, every company has a different answer to that. We encounter that with almost everyone we deal with. Same thing, Quadro versus GeForce, or Xeon versus Core i9. It's always a gray area.
The exciting thing is that I think that, like, so doing software development and doing the development stuff on a workstation like a Threadripper workstation, and whatever, I used to be really excited in university because it was like I would develop my program on my crappy little computer, and then I would upload it to the university mainframe, and it was dazzling how much faster the university mainframe was. And now I'm sort of finding the opposite. It's like I work on my program on my Threadripper system, or my Skylake X system or whatever, and it runs great, and then I upload it to Amazon and it just runs like garbage. And sometimes that's the clock speed, sometimes that's because I'm on the crappiest plan ever. Sometimes that's because I only bought like the Xeon Silver, like 4116, like 2.6 gigahertz. I think those are like 4 or 6 cores in like a dual socket configuration. It's like, this server is crazy. why would I ever want two 6-core CPUs that don't even really clock worth anything? But that's still like a $5,000 server versus my, scrappy little $1,500 or $2,000, $2,500 desktop. And so things have really flipped around because the servers are still crazy expensive. But in terms of like raw compute or anything like that, that's not really what you're buying anymore. It's the PCIe lanes and the memory support and all that kind of stuff.
Yeah, yeah, yeah. I think once you have to take like massive scale into account, it's a very different ball game than just having a box on your desk, or even just servers that you have in your server room for local serving.
Yeah, yeah. It's an exciting time though because that means that people have access on their desktop to basically cutting edge computational horsepower, and that's also true with GPUs. I think. What about like Quadro versus NVIDIA
Or versus GeForce.
or GeForce? Yeah, yeah.
Yeah. That's a tough one too, because you have Quadro that's put out for very specific software applications that they're certified for, and yet you can get if it was just a question of like cost and reliability, it wouldn't be quite as difficult. But when you can't match the performance without going, say, Titan, then yeah, I mean, you have the software manufacturers are actually very incentivized to support GeForce because then they have access to all that performance because it's better for their users to give better performance.
Yeah,
So,
and it's frowned upon to use GeForce cards in the data center now.
oh yes, oh yes. And we get to experience again right where those lines blur because we don't do a lot of data center work actually. We do most of the work that we do even on the server and HPC side is with developers because I think once you're like going massive scale, it makes more sense to just go massive scale. Go to the cloud, go to HP or Dell. Like they can handle. They're built for that, right? But when you're a developer just kind of getting started and you're writing your code and you need to know how the code scales across different hardware platforms, like that's what we do. That's where we live. And so we end up doing, even if we do rack mount, a lot of times it's going into an office or a university lab or something like that. So then it becomes, okay, well, if NVIDIA is going to have rules about going into the data center, like what's the data center? And so we have to have conversations all the time. Like, is this okay? Is this okay? Yeah. Yeah.
How
It's
did
hard living. It's hard living in the gray area.
how did you guys experience the was it the Titan V drivers like where they like everybody was bugging Nvidia to update the drivers and then they updated the drivers and then all of a sudden we had Quadro performance from the Titan.
Mm.
Was that a thing? I don't remember.
We didn't really experience that. And I think probably because where we use Titan V, um, where we saw the most use case with that was again in like rendering and machine learning. Titan V is a pretty amazing card, but not necessarily like we see like there's absolute performance gains for Quadro in say CAD design. Was it Autodesk and Inventor and SolidWorks? Outside that, once we're making developer boxes, we tend to be on the Titans.
Yeah, I did. I had a big rendering project a few years ago. We modded some 8800 GTXs to be Quadros. They work
Okay.
fine. You can't do that anymore. It doesn't work that
Oh,
way anymore.
right. They fixed that, right?
Well, it's not that they fixed it. It's also that the hardware kind of diverged. I mean, there's a little bit of overlap at the low end, I guess, but at the higher end, NVIDIA has really done a lot of R&D and a lot of really interesting stuff with like the new hardware and the new silicon. But in those days, it was like, you got to differentiate products somehow, and it's like we'll just do it with an EEPROM.
Yeah, what's been great for us is when NVIDIA launched the GP100 and the GV100, where we actually had, because a lot of times when we're doing developer boxes, we have to have those video outputs. And so the Tesla cards aren't so good for us, and the Quadros don't have the performance our users need. And so the GV100 and the GP100 are great. Those are doing really well for us. And then the fact that they have so much memory on board, it just opens up all these different use cases that you could not get on the GeForce side, which is exactly what they want.
Have you guys done any experiments with the card from AMD that has the onboard NVMe? I always wondered how that would play out for the workloads that needed a ton of memory for stuff.
We did. We played with it a lot, actually. It's one of those things where you have to have a really strong software support for it to really make sense. And there are some software platforms that I'm pretty sure Premiere uses it, and I think Resolve does as well. Um, it's one of those cases where you not only have to be on board with using the hardware, and it's pretty expensive hardware, but then you also have to be on board with using it in the way that they built it to work. So like with Premiere, I think was it like a 2 terabyte NVMe drive on board?
Yep.
And so in order to do that, we have customers, you're doing 4K, 6K editing, and 2 terabytes isn't very big. It's not big enough to do native work with files of that size. So then you have to get into working with proxies, and that's fine. You can do that, but you have to be okay with like, okay, you have to use Premiere in this way in order for this project to make sense. So I think that limited its adoption a bit.
That makes sense. Yeah. And then I think the last thing on our chat list was also to talk a little bit about Meltdown Inspector and the coming hardware changes. And I think that will probably be good in general for hardware sales, because Meltdown Inspector are so bad that all the software fixes so far have been like super half-assed. And it does require new computer science, which means that, it's not just going to be AMD and Intel that are fixing this. It's going to be, ARM is going to have to fix this. Qualcomm's going to have to fix it. I mean, there's just like pretty much everybody that has a processor that does speculative execution is going to have to go back to basics and really sort of re-implement how they do speculative execution in order to fix this in hardware, which is probably going to lead to a lot of hardware sales, a lot of cheap CPUs on eBay. I mean, I bought some Xeon E5s on eBay for like $70, and it was like, oh, this is the deal of the century.
Yeah, I mean, we were, I think, where we live in building workstations for content creation, engineering, and scientific, because we deal with more the workstation and we're more on like the developer side of the cycle than when things go into like production servers. Yes, I mean, it affected us, and we had to implement the fixes, and there were all the security concerns and whatnot. But from a performance standpoint, it didn't affect our workloads very much. And beyond just kind of in general, you need to have good security practices. Like we didn't have as much risk in the kind of workloads our customers do, right? We're not running multiple VMs that can speculate and get data across. So the actual business risk to our customers wasn't as great.
I'm not really sure if the audience really understands that, but just to explain. So like if you're Amazon or you're somebody that is running a set of computers with multiple customers, you can no longer guarantee that the virtual machines for different customers can't talk to one another. Like that was a thing that was taken for granted until very recently. And now, if Amazon is renting a box and some of it is Netflix and some of it is Joe Random Hacker, potentially Joe Random Hacker could take over Netflix's image by stealing the encryption keys or stealing the SSH keys or stealing the private keys for, the SSL cert or whatever. And so that means that Amazon has got to be extra double plus sure that all of the mitigations are in place. Otherwise, one customer could steal another customer's information. So for like cloud service providers and things like that, it's problematic. Probably not as problematic in a university scenario or researchers or academics. Or it's like, I'm running my own stuff on this. I'm not running random crap from the internet.
That's true. Like we run a server rack here, and it's all our own virtual machines. And yes, there is still additional risk associated with it, but it's much less than like anybody off the street could fire up an instance and have access.
So it is an exciting time to be alive because there's so much new computer science, and it seems like everything is moving at a much faster pace than it was a couple of years ago in the server space and the workstation space. But the best is probably yet to come. I've got some experiments going. I've got a Cavium Thunder X2 system from Gigabyte, and it's like, let's abandon ship and see what. I'm still doing testing on it and that kind of thing, but it is really exciting because early tests, it does look like Player 3 has entered the game. It's a good, it's not. To be sure, Intel and AMD have like insane performance per dollar, but it's not a bad value for things like web server type workloads, compiling, like using it as a development server where it's just running continuous integration builds and things like that. It seems particularly well suited for that. And a lot of my interest in the alternative architectures has been because of things like Meltdown Inspector.
Yeah, well, that's interesting. I haven't played with that at all myself. How's it been? How's it been so far?
So far pretty good. It's I've only used Red Hat Linux on it, and it's like Red Hat and SUSE and Ubuntu are pretty well supported, and Oracle has a version of their Linux that is supported for it. It is a dramatic improvement over the first generation Thunder processors, the original Cavium Thunder processors, but it's the platform, the overall platform latency is surprisingly low, and they kind of cheat a little bit about that because the processors have 8 channels of memory each. And it really, you need to run all 8 channels if you want to keep all of the processors fed. And so it
Okay.
works great for things that are massively parallel, like web server type workloads. The particular system that I'm
Mm.
using is a dual CPU, and the interface between the CPUs seems pretty quick too. But the Windows or the Linux scheduler seems really great about being able to move workloads between different nodes, and it works great. And at VMworld, VMware announced ESXi support for this platform. So
Wow.
I haven't tried that yet, but that should be
Hmm.
really, really interesting.
Yeah. Yeah. Interesting. Yeah. No, we haven't looked at that, but when open power became a thing a few years back, we were looking at that. Because again, like I said, that's when machine learning was just taking off, and we were do a lot of boxes for that. And having NVLink on the open power side was a big draw, and so we were looking at that, but didn't end up going down that road. Didn't have to.
Yeah, well, the Talos 2, I mean, that'll be the next thing. So, all down with x86. It's all to no. I don't really think there's x86. Sadly or not, has a lot of life left in it, and
Well, and boy, I mean, there's so I mean, the software developers haven't even caught up with the core race yet.
yeah,
Let alone get onto another platform. So yes,
yeah,
it'll be a very long time.
yeah. I mean, just well, Windows is trying. Microsoft's trying that ARM version of Windows. That didn't work out well for them. They did this. They did the to do we almost bought one. I didn't buy one, but it was. I'm given to understand from other reviews that the Windows on ARM thing was not the greatest, even though it
Yeah.
had the real time x86 emulation or whatever. So, well, can you think of anything else? You want to take some questions real quick? We're running a little over, but that's fine with me.
Yeah, sure. We can take questions.
Anybody have any questions from the chat?
And then we wait 30 seconds for the questions to start.
Well, I think I totally forgot to talk about the potato chips. What, at the beginning of the
Oh,
stream, it was, while we were waiting to go live or whatever, it was, what is chat's favorite kind of potato chips? And I think Christo said that she was Grippos, which I could get behind some barbecue Grippos. That's not bad. I'm not really a potato chip person. You know what? I'm
yeah.
Devil's Food cookies. Those and
Okay.
pinwheels. Like it's like a marshmallow chocolate thing with a chocolate cookie underneath. Oh, that's how you do it.
Never even
That's a
heard of it.
snack food. Yeah,
I feel like I'm outside my area of expertise now.
snack foods. Like what snack foods do you like?
What snack foods do I like? Oh, I don't even know.
Well, we've got a box of Soylent in the break room, so there's that. No, I'm just kidding.
Questions I'm not prepared to answer.
When dual socket Threadripper, so dual socket Threadripper is not happening, but you can get a dual socket Threadripper like system that's based on
Yeah.
Epic.
Hmm.
So that was not a great question. I'm sorry, whoever asked that. Can you test GPU pass through on laptops, or is that difficult to talk about? So GPU pass through on laptops is going to be challenging because of the physical hardware implementation. There are a couple laptops that support it, but depending on how the frame buffer is passed from the real graphics card to the iGPU to be displayed on the real LCD, that can kneecap you immediately on pass through on a laptop. It would be much better if AMD and NVIDIA would support SRIOV on consumer level graphics cards, which you guys probably have worked with SRIOV graphics. Well, maybe, I don't know. But Intel is supporting SRIOV on their iGPUs, which seems insane.
Yeah. No, it isn't an area we've had to get into very much. I know you do quite a bit. What's your draw to GPU virtualization? I see a lot of videos from you on that.
I think that the if we ever have like if the year of the Linux desktop, so well
That's this
when
year, isn't it?
yeah, I mean just when Microsoft Excel, like before Microsoft Excel, there was Lotus 123, and Lotus 123 was everywhere, and it was like the spreadsheet application way back in the 80s. And when Microsoft Excel took over for Lotus 123, the magic feature was not that Excel could open Lotus 123 files, which it had pretty much since the beginning. It was that it could save Lotus 123 files. And the people that run the business at Microsoft were like, we don't want to save as Lotus 123 because what few people that we have on Excel might want to jump ship and go to Lotus 123. And ultimately that was short-sighted. And actually the best thing, because Excel was actually a better product in some ways, a worse product than others, in order for the consumers to adopt it, they needed to add save as 123 in Excel so that somebody could switch to 123 or switch to Excel and still be able to participate in the 123 ecosystem with other businesses or people in their office or whatever. And so I think that when people can pack up their Windows existence into a virtual machine and continue to use it with full performance on another platform, that will bring about the year of the blank desktop. Now, I don't know if that's the Linux desktop or FreeBSD or some other, hitherto unknown operating system, but I think that being shackled to a single operating system is dangerous for humanity as a society, like just dangerous in general. And I don't really think that like cloud services platforms are the way to go either. And so if you can pack up your Windows experience and with no friction at all, completely switch platforms, I think that in general that'll probably drive adoption of things other than Windows, or at least people will feel less shackled to that ecosystem. But more importantly, it will let us move forward with new computer science that is necessary for massively parallel things. Like in the future, you might have a computer that's 64 cores plus a quantum coprocessor plus like 40 tensor cores or whatever like that, and it's all in one box, and whatever operating system is written for that, you need to be able to still run your old stuff with full pass-through. Now, I like to imagine a future where that's Linux, but I don't know that Linux is really written for quantum computers either. But in order to be able to do that, we need, sort of ground truth support to be able to do that.
Yeah, that's cool. Okay, that makes sense. Yeah, I mean that opens up use for new hardware as well as new operating systems. If you want to update your platform and everything is kind of this like bare metal hypervisor approach, then no sweat.
Yeah.
Can you imagine getting your new computer and like you're up and running in a couple minutes because all you did was drag your virtual machine over?
Yeah,
It'd be great.
Intel kind of had the same, like when they were doing the Itanium. Remember the Itanium? I also
Mm-hmm.
like to call the Itanium the Itanic. But Intel had kind of the same thought with the Itanium. They were like, we need to update everything, and we're going to do the Itanium. That's going to be our 64-bit solution. And our idea for running things in parallel was to put this crappy x86 32-bit processor as like a coprocessor on the Itanium. And then when we get fast enough with the Itanium, we can just do it in software. That was a disastrous, terrible, terrible execution. But, Intel is not full of dumb people. That was a good idea. Like, there was some good stuff there. And being able to do that means that you will be able to move super quickly at the speed of whatever new exciting thing comes out. I mean, with the way
Yeah.
that things are moving with GPUs, I mean, pretty soon we might see, an NVIDIA motherboard that's designed for, well, we already are, the Teslas. The specialty motherboards where you've got like 4 or 6 or 8 Teslas on one carrier card. x86 is going to be a thing that you add in to be able to run x86 stuff and control it like the old school clusters, but really all of the computation is done by this massively parallel set of Teslas, or in Google's case, a massively parallel set of their proprietary designed tensor cores or whatever.
Yeah.
So,
Yeah.
but we need that on the desktop.
That's cool. Yeah, that's a good thought. Yeah, I mean, with all the different hardware back and forth that's going on right now, it's actually, it's easy to buy. Well, now you can buy a computer that's really good for what it is you're doing right now, because there's all these different options. But how is it going to be in 2 years? And is there a missed opportunity you're going to have because of this back and forth game? We launched recently a subscription option to our computers, and everyone has subscription options, right? And it wasn't, it was because of that. It was because we knew that. So I'll give an example. Like what was it? It was either Lightroom or After Effects. I think it was After Effects. As they updated from one version to another, it like completely changed the way that hardware profiled, and it went from.
I remember that.
I think it went from like super. It was scaled really great to like now it's all about frequency, and that was kind of painful to us because it was things like last month we were selling the best thing for After Effects, and then if you did that software update, you now have a really terrible machine for After Effects. And so we have to respond to like the hardware changes and the software changes. And so that subscription option gives us the ability to like, okay, whenever something new comes out, you just like swap it out and keep your payments going. It's like the reason that's why we did it. So there's just so much change happening right now in the industry.
Mark Yates asks, as a builder, are benchmarks post-build worth it? And I think the answer is yes. That's probably a good thing to do like once a quarter just to make sure your system's performing correctly.
Well, make sure it's stable, and then do benchmarks over time to see if anything's happened, I guess. Um, yeah, I think you should know. It's like what you built the computer for, is it effective at doing that job?
What do you think will happen when Windows 7 security updates end? It's going to get it's going to be Windows XP all over again when it turns into a botnet.
Yeah, you're probably right. Oh no.
Question for John. What types of hardware optimizations are good for .NET DevOps compile time reductions?
Holy smokes, that's a very specific question. I don't know that I can answer that off the top of my head, but we have people that can answer that.
Kevin, let me direct you to the Puget Systems contact form.
Right. We can answer that. I don't know if I can answer that off the top of my head. I think, well, you probably could, right? Because you do a lot of code compiling, isn't it? You need a lot of memory.
You need a lot of memory, and you need a lot, like, just more and faster cores. Like, if you're compiling on a Xeon non-W system, it's going to be a terrible, painful experience. Reducing I/O latency, so like Optane, even though like I have an Optane, like a 480 gig Optane drive, because I can't afford 512 gigabytes of memory. I have one project that I'm helping another person with, and it needs like 400 gigabytes of memory to run on this particular one problem set. And so I've got 128 gigs of memory in the system, but then when I hit swap, I use Optane, and that actually is not almost. I mean, that sounds really bad, like using Optane as RAM, but it actually has been fine. And it's the workload is just like super random. It's not really super hot I/O intensive because it has to do a lot of computation on. It has to basically take this massively parallel thing and then walk a tree and do all this kind of. It has to do with source code control, like conversion from one source code control system to another. And we're fixing it in software so it doesn't need so much RAM. But used Optane as a way to deal with that, and I was surprised at using Optane both as a source disk for a billion tiny little files with a file system that can handle that well, like XFS, to using it when you run out of RAM actually worked really well in that scenario. So I'm not sure about the
Yeah.
.NET side of things, but I would say that having a file system and an I/O device that supports really fast I/O with a bajillion tiny files, which is probably not NTFS, is good.
I think that's one of the strongest use cases for Optane. I'm interested in your take on it because using Optane as an OS drive SSD, we haven't found that there are any workloads that saturate NVMe that becomes a bottleneck for us, let alone having to go to a more expensive technology like Optane.
No, you're
So
exactly right.
so it's just like it's this really expensive SSD, but it's really cheap memory,
Yeah.
and so that does make sense.
It's funny because Intel's NVMe was not really optimized for the random I/O workload, but with the Samsung 960 and I never figured out a way to succinctly turn this into a video, but with the Samsung 960 Pro and 970 Pro, Samsung is doing something with the memory on that and the flash on that. The 970 I think has some single level cell memory, and the 960 is whatever they did. And the random I/O of a billion tiny files on the 960 approaches the performance of the 900. And I don't know how they did it because it's NAND flash, but the Intel NVMe performance is pretty terrible. Like for that workload, for a billion tiny files of random I/O, I don't think Intel really did any software optimization. Their firmware on their NVMe is probably rock dumb simple, like, oh, okay, we've got an I/O, let's go do it. I don't know how Samsung sped it up, but somehow how they've arranged the cells or how they're doing I/O, or they're caching things to memory dangerously, or they've got a big ass capacitor on there so that it can write out memory when it's full. I don't know what they did, but the Samsung NVMe drives perform really close to that Optane for all of that. But then you hit a wall, and when you hit the wall, then it sort of degrades to NAND flash speeds. But for compiling, it's usually like I need a bunch of I/O, and then the CPU's busy. Then I need a bunch of I/O. And so in that, like, busy, not busy, busy, not busy, the 960 works fine, unless your code base is just insanely huge.
Isn't that crazy how specific you have to
Yeah,
be when you're going through this? Like, it isn't enough to even like, okay, we're going to build a workstation for, or you're going to do a server for web serving. It's like that's not enough information. You have
yeah.
to work with that client and figure out their code, and then you can figure out what technology is best.
Yeah, yeah, it is really sort of frustrating and annoying because, and then you get people that are like, I'm working on this project. He goes like, just buy something on Amazon, and it's like, no, you don't understand.
Yeah,
If I could just cut a check to that's not you. You don't need the Amazons. You need the people that know what they're talking about, like Puget Systems.
great. That worked. That worked well for me.
So thank you again for having me, or thank you again for me having you. I don't know. I forget how
Yeah,
that works. So
yeah. Thanks for.
it's been a lot of fun. Hopefully we can do this again. Maybe we can. I would love to do a stream of like a case study or something. So if you get in mind
Okay.
of like here's a client, here's an academic client or somebody that doesn't mind sharing details, and it's
Yeah,
like here's the rundown of like what their problem was and how we interviewed them, and here's the thing that we built for them. I think that would probably be pretty interesting
yeah. We should
for
do
the
that.
audience.
I don't know if
So
you have the same experience, but the best customer stories we can't talk about.
yeah, yeah,
But
yeah.
occasionally we can, and so yes, that would be a lot of fun. I mean, because that's what we get out of bed for is getting our customers' work done, and so hearing their stories. So there's some cool stories. There's ones
Yeah.
we've shared of like we have boxes that are being used for astronaut training in VR, and it's really cool stories. So
That's awesome. Yeah, that's exactly the kind of stuff that makes for cool content. So thank you again for joining me for the live stream. It's been awesome. I don't think we've got any more questions. I think that's pretty much it.
okay,
So
all right. Well,
it's awesome.
thanks
Well,
for
I
having me
will
on.
see you guys.
Bye.